All right, here we go. Last lesson on the different types of equations, right? We went over the basics, the 1 step, 2 steps, then we added combined like terms and distribution, right? Longer ones that we can have, right? And the goal, if you're following along on the notes that are attached to this lesson, we're gonna go over the first thing, right? The goal was always to keep the equation balanced, right? We really only have one rule with equations, right? It's whatever you do to one side of the equation, one side of the equal sign, you have to do to the other. So that's still going to be true here, right? Our goal is to isolate the variable, to get the variable by itself. Now, up until now, we've always had like 4x plus 3 equals 12, right? Something simple, and we only had a variable on one side of the equal sign, and we would try to get it away, right? Today, we're going to have it where there's a variable on both sides. So 5x plus 3 equals 6x plus 2, or something like this, right? I have my line that I drew, and I have an x over here, and I have an x over here, right? I have all of these things. I have a variable on both sides, right? Now, the way that we're going to do this is going to be simple. The first thing we're going to do is we're just going to move all the variable terms to one side of the equal sign. We're going to use the same rules that we've been doing. Now, there is no wrong way to do this. There is no, you can pick which one to move and you will be right either way. I'm going to give you a little tip that I use in order to keep things positive, right? I think we should avoid using negative numbers whenever we can. So I call it the tug of war, right? So let's pretend there are doing a tug of war, right? You're back maybe in elementary school, you're at field day, you gotta do a tug of war, right? So over here, forget about the constants for now and just look at the variable terms, right? You have 5x over there and you have 6x over here. If they were in a tug of war, who is most likely to win, right? If you have 5, let's just say those are 5 people, and let's say they're all of equal strength, right? You have 5 people over here, right? 5 x's. And then you have 6 x's over here. If they're all of equal strength, you would assume that this side would win the tug of war, right? So that would pull these guys over to this side. So that's essentially what we're going to do. We're going to play tug of war with the variable terms. So we're going to have whichever has the greater coefficient, we're going to pull to that side. It doesn't technically matter, but that's what we're going to do anyway. Okay, so let's go to the examples. The first example here, 5x plus 7 equals 3x plus 13. Now you can see your steps. Your steps are pretty much the same, they're written there, right? Our step 1 is always going to be draw a line. I think that's important, particularly when we're doing these, right? So we draw that line. Now, second step is going to be move variables to one side. I have 5x over here and I have 3x over here. So I'm going to move one of them. It doesn't matter which one technically, but if I have 5x's and I have 3x's, the 5 will win. So I'm going to move that 3x over to the other side. To get this 3x to cancel out, right, this is positive 3x, I need to subtract 3x. So if I do it to one side, I have to do it to the other side. So 5x minus 3x is 2x. I bring down the plus 7, I haven't done anything with that yet. That cancels, and it leaves me with just 13 over here. Now from here, you should recognize pretty simply that this is just a basic two-step problem from here. And this is no different than we did a couple lessons ago, right? So I would subtract 7 from both sides because I need to get rid of the constant first. That'll cancel. That'll leave me with 2x equals 6. And then, of course, divide by 2. And you leave me with x equals 3. And that's the answer. Now, of course, you can plug in and check yourself real fast. Put a 3 in. 5 times 3 plus 7 equals 3 times 3 plus 13. 5 times 3 is 15 plus 7 is 20. 3 times 3 is 9 plus 13 is 22. So those both equal 22. So that one is correct and finished. thing we're adding is that first step today. So example 2. Do that in black to start. 4x minus 3 equals 6x plus 15. First step, as always, remember, draw a line and keep, change, change if necessary. So I'm going to keep, change, change to plus negative. I have 4x, I have 6x, they're on opposite sides, so I'm going to move the 4x over, win the tug of war. The 6x would win that tug of war, right? So that cancels. It leaves you with negative 3 over here, 2x plus 15. Okay? Now, basic two-step equation from here. Subtract 15 from both sides. That gives me negative 18. That's a little tricky. That cancels. 2x equals negative 18. Divide by 2, and you get negative 9 equals x. And again, you can check that, you can plug that in, and you will get the same answer. Okay? That's the first two examples, and that's pretty much the only difference today. We're going to look at one real quick to make sure that we can establish the difference between the type of problems that we're doing here. Right, so if you look at the two problems that are there, you have A, you have 5x plus 3x plus 4 equals 20. Right? You have this. If you go to draw your line, this is why we draw a line, so it's easy to see. The variables aren't on opposite sides, right? They're on the same side. So this means that you should just combine like terms, right? So that would be the blank, right? Combine like terms. The first step in solving this problem would be to combine like terms. It would be to add 5x and 3x, you would get 8x plus 4 equals 20. You would subtract 4, you get 8x equals 16, divide by 8, and you get x equals 2, right? They were on the same side, so that means combine like terms. When they're on opposite sides is when you have to do the tug of war. So, for example, then look at B. 5x plus 4 equals 3x plus 20. Now, if you don't pay close attention, those look kind of the same. We use all the same numbers, and they're kind of the same. Except for, when you draw your line, you realize that the x's are on opposite sides. So if you go to solve this, the first thing you would have to do is move this 3x over to the other side. Right? That would give me 2x plus 4 over here. That would cancel. That would give me 20. I would subtract 4 from both sides. Now I get 2x equals 16. Divide by 2, you get x equals 8. So over here we got 2, and over there we got 8. So very clearly those are different problems, even though they look pretty similar. Right? So the first step there was to move variables to both sides, rather than to combine like terms. Okay? So just be aware of the difference. It's already typed there, but if the two variable terms are on the same side of the equal sign, right? They're just like this. Then you combine like terms. You just add them together. If they're on opposite sides of the equal sign, then we have to pick a side and move them all to 1. Again, it doesn't matter which one, but I think it's easier to play tug of war, move them all to the side with the bigger coefficient, and you can get it better. Okay, go to the next note sheet there, and we're going to do these last two practice problems, and then of course you will go on your own to do a whole sheet full of practice problems. But the first one here is negative 4x plus 6 equals 7x plus 28. Right? These are on opposite sides once we draw the line, right? We have a negative 4x and we have a positive 7x. If that were to do a tug of war, who would win that? Well, the negative number is never going to beat a positive number, right? That's like having nobody on your team versus having 7 people on your team. So you want to add 4x and do the opposite of that. That was negative 4x, so you got to add 4x to both sides. That leaves you with just a 6 right here, 11x plus 28. basic two-step equation from here. Subtract 28, subtract 28. That leaves you with negative 22. Remember your rules for that? That cancels, leave us with 11x. Divide by 11. That leaves us with negative 2 equals x. So x is negative 2. Last, you can plug that in and check that. Last example, 6x minus 3 plus 5 equals 3x plus 11, right? A little more complicated, but really nothing crazy here. Draw your line, take a look at where your variables are. You got them on opposite sides. You got a 6x over here, you got a 3x over here. So the first thing I want to do is move everything to one side. All the variables to one side. So I'm going to subtract 3x because that would lose the tug of war. It would pull it over to that side. That gives us 3x minus 3 plus 5. Bring everything down. That cancels, equals 11. All right, I should have changed this, so I'm going to fix it right now. Should be plus negative 3. Now you can combine these right here, or you can move them separately. It doesn't really matter. Let's just say we're going to combine like terms. So that'll give us 3x plus 2 equals 11. Right, I added the negative 3 and the 5. Now it's a basic two-step. Subtract 2 from both sides. That cancels, leaves you with 3x equals 9. Divide by 3. And x will equal 3. Okay? That's as complicated as the equations get. Now obviously, you could see some problems where they add stuff, they put everything together, but really, as far as the skill set that you need, you have all of the basics solving equation skills down. Okay? Check the practice problems, we'll be back with the answers.